Alright, so last stone weight. We have a collection of stones. Each stone has a positive integer weight. Each turn, we're doing some kind of simulation. We choose the two heaviest stones and smash them together. So for every iteration, we want to get the two heaviest. So we're looking at some kind of maximum priority queue. Suppose the stones have weight x and y, with y be the heavier one. The result of smashing them together would be, if they are the same weight, they just destroyed each other. If y is strictly heavier than x, then x will be destroyed and the y's weight will be decremented by the weight of x. So I guess we push this back to the priority queue, push the remainder back to the priority queue. In the end, there is at most one stone left. We need to return the weight of this stone. So here is the example 2, 7, 4, 1, 8, 1. So in the first iteration, we grab 7 and 8. The difference is 1, so we push a 1 to the end. We end up with a new collection of stones with 2, 4, 1, 1, 1. Then we smash 2 and 4 together. The remainder is 2, so we push it back onto the priority queue. Next iteration, we grab 2 and 1 and push the difference back to the priority queue. Then the 1 and 1 cancel each other. We push nothing back to the priority queue, and in the end, we left with one stone with weight 1. So that's the value we return. Yeah. So this question is really straightforward. We're just going to use a priority queue to simulate the process. The time complexity will be n log n. Log n is time complexity for the for the pop and push operation with priority queue, and n is that for each iteration we extract 2 stones and we at the most push back 1. So the size of the problem is decremented by at least 1 in each iteration. So since we started with n stones, it's a linear in terms of number of iterations, guaranteed. So it's n multiplied by the time for the n is for the loop, n is for the log n is for the operations. So it's n log n. And space, it's linear as well. So I guess we wouldn't really do this in place with this because that would just destroy the values if it could be potentially used in somewhere else. So yeah, we were passing. We want to make a copy of the stones and push that copy onto the priority queue. So let's code this thing up. We have a priority queue of integers, which we initialize by copying the copying and making the values into the heap ordering. And then we will just simulate the process until we left with less than or equal to 1 stone in the priority queue. Size. If we have more than 1 stone, we can always do a smash. We will extract the 2 heaviest stones, weight 1. It's PQ dot back at the top. I forgot. And after we extract the value, we should pop it off as well. We do the same thing for a stone of the second largest weight. And if the stones' weights are not equal, that's the only case when we need to push back a smaller stone. Since S1 is W1 is extracted before W2, it's guaranteed that for this maximum a priority queue, W1 is guaranteed to be larger than or equal to W2, so we can just push the difference on back to the priority queue. And once we terminated with the criterion that it's less than or equal to 1, if it's 0, if it's empty, we just return 0. Otherwise, it would just be the only number that's left on the priority queue. So the condition would be pq.empty. Yep. So this is a code that's pretty straightforward. Let's see if it works. Yeah, it's working. Okay. Alright, so this is a question, Leetcoding question for today.